So I'm going to show you an example of the hypergeometric distribution in this video. So suppose that a group of statistics students is divided into two groups. We have STEM majors and non-STEM majors. So let's say there's 20 STEM majors in the group and 12 non-STEM majors. And so let's say also that we want to select five students from this group randomly. So we have a couple of questions here. So first is to describe the random variable x. So the fact that this has been broken up into two separate groups within an entire group, so right, there's 20 plus 12, there's 32 students in total, but we've been told how to divide these up. That is one of the signs that we are talking about the hypergeometric distribution. And then the fact that we talk about STEM majors first, it's usually whatever you talk about first that is that success group or that like first group that we're interested in. So if I'm asked to describe the random variable x, this will just be the number of STEM majors in the sample, okay? And that is literally just because STEM is what came first. So if it said non-STEM first, then we would center this around non-STEM first. So, okay, now that we've talked about that, now what we want to do is we want to make a PDF table based on how many ways we could choose 5 STEM majors from this group. So we're going to need Excel, and once we set up a table, we should be able to answer these other two questions pretty easily. Now, I set up my own Excel workbook. Typically, I have an Excel workbook that I share with everybody, but I actually want you to be able to create this from scratch. And so I just want you to notice what things I've already set up. I have my X, so my X is going to be my number of STEM majors. So remember, we're picking 5 students in total, so I need my probabilities to go from 0 to 5. But X is going to be the number of STEM majors that I choose. And so now what I need to do is I need to calculate my P of X. And so I want to make one draggable formula. Now, since we're talking about the hypergeometric distribution, so there is an Excel formula for this. If I just type in hype, you'll see that you get this hypegeom.dist. So I'm just going to point that out. That's hypegeom.dist, but you can make a pretty good guess as to what that formula needs to be. So this is going to be what calculates our different probabilities. So let's go ahead and set this up. Hypegeom.dist. Okay, so now this is asking for different pieces of information. And some of this you just kind of have to get used to. But so the sample S, this is talking about how many we've selected. So how many did we select? Now, in this instance, you'll notice that my formula has now gone over. It's like spilled over. The first time I want to calculate this is for 0 STEM majors. I can't see that, so what I can do is I can just arrow over to where I know that reference is. I know the reference is right here, so you can kind of see that box it's like highlighted behind the formula, right? Okay, so in total, so my number S is going to be 0 to start, and then this is how many are in the sample total. So we're breaking this out for specifically STEM majors, and we said that there were 20 STEM majors. Then it's saying population S, and so this is now asking for how many in total are we selecting from the population? That would be 5, and this would be how many total are in the population, and that would be 32, and this is going to be false. And so if I type in all of that information, you can see here that calculated one of my probabilities. And now specifically, this is the information that needs to change, this X value. So I have referenced this cell. The rest of these aren't going to change, right? I'm always selecting 5 from the population. There's always 20 STEM majors. There's always 32 total. So all of this other stuff stays the same. So if we wanted to just write out some prompts for this. So it's the number we want to calculate the probability of, and then the total number of options in the subgroup, and then the total number selected from the population, and then the total in the population. And then you always follow this up with false. So this is an alternative way to think about the prompts, although honestly, once you get used to the prompts, you should be used to what it's asking for. And okay, so now I should be able to just drag this down. And okay, so now if I sum this up, so let's see, if I just do a quick check. So if I take the sum of all of these probabilities, you'll notice that I get 1. So I feel pretty good about my table. If your table doesn't add up to 1, then that means that one of your inputs was incorrect. Okay, cool. So now I can ask some of those other questions that we had. And just to make our lives easier, so I have the 2 questions right here. So what is the probability of selecting 3 or more STEM majors? Well, once you have your PDF, right, you can just go ahead and sum this up, or I can go ahead and just enter in sum 3 or more would be those 3 probabilities there. So the probability of selecting 3 or more STEM majors is going to be about 74% is what we could round that to. And what's the probability of selecting 1 STEM major? So only 1 STEM major would be about 5%. And okay, so if we think about this right, these numbers also make sense because remember, my number of STEM majors, there were 20 STEM majors and my non-STEM majors were 12. So my STEM majors make up more than half of this group. And so it seems extremely unlikely, almost close to 0, that we would select no STEM majors, right? And even selecting only 1 STEM major, this seems pretty unlikely. So it feels like we're more than likely to get at least 3 or more. Okay, and so that brings us to the end of this one. I will catch you guys in another one.